Thank you all so much for coming to our biannual symposium, and thank you for caring about clean water in the state of New York. I'm going to talk about our non-proprietary nitrogen-removing biofilters that we have promulgated here in Suffolk County, and then I'll briefly talk about nutrient removal and recovery project that we have ongoing. So the way I'm going to do this, Chris had already talked, and some of the earlier speakers have talked a lot about the problems of nitrogen pollution in Long Island and the county subwatershed plan. So I'm going to cut through that pretty quickly, then talk about our NRBs, our nitrogen removing biofilters. We have 3 different designs of those, and then briefly talk about coupling which of biofilters with some of the other proprietary commercial products that are in the market that can make those technologies do an even better job. And then again on that nutrient recovery and reuse project. So Chris did a good job with this. Suffolk County's solution when the population was increasing so much in the middle part of the last century was the cesspool and subsequently septic tank and leaching ring. Those technologies do not remove nitrogen, nor do they remove any emerging contaminants. That saves some money in the short term, but not a great solution when your drinking water aquifers sit underneath those cesspools. So what's the state of those aquifers now? About 10 years ago, DHS did some work which showed consistent nitrate increases in both the Magathie aquifer, the cleaner Magathie aquifer, and the one above it, the upper glacial. And we took a look just recently at some more recent data, and those increases continue to be sustained. But not only does the nitrate in our aquifers keep going up, it's already at a very high level. So USGS monitored nitrate from public supply wells all over the country from 1988 to 2018. In that period, the median for nitrate in those wells was 0.4 milligrams per liter. So you look at the upper glacial, we're approaching 10 times the national average. So most of that water, as Chris has described, most of that nitrate is coming into those estuaries from on-site wastewater, about 2/3 of it. That's a problem for 2 reasons. One, Chris has already discussed, really negative effects on our estuaries and embayments, harmful algal blooms, algae blooms, fish kills, and loss of salt marshes, collapse in fisheries, shellfish fisheries. But there's a second issue as well, which is that elevated nitrate is a public health concern. So the World Health Organization categorizes it as a probable carcinogen. The EPA set an MCL, that's a minimum contaminant level, of 10 milligrams per liter, and that was to prevent something called blue baby syndrome, which is a very serious illness, but a very rare illness. And that was done decades ago. In the intervening years, there's been more and more epidemiological research done on the health risks of nitrate in drinking water, particularly related to various cancers, but also birth outcomes. Some of those studies were inconclusive, but dozens of others found nitrate relationships with those illnesses at levels much lower than the EPA, the current EPA drinking water standard. The good news here is what you already got a bit of an idea about, which is that the politicians here and the authorities in Suffolk County are really committed to solving this problem, and they've got a great plan called this Subwatersheds Wastewater Plan. It has feasible It's a very comprehensive, and it has feasible, achievable solutions. So in addition to making funds available for sewering and for paying for conversions for homeowners to nitrogen removing systems, it also sets up a permitting process. And that permitting process has been very effective at identifying solutions that work and ones that don't. So we don't waste our time and money with what doesn't work. And so the systems up here that are approved, there are 7 of them. They're available for commercial use, either in provisionally approved or general use permitting. And they're all good. 5 of them are proprietary systems, and 2 of them are non-proprietary systems. We make these designs available for anyone who wants to install them. So, and you can see here, all those systems that were just on the former page, they all do well better than the 19 milligrams standard. And then the ones that don't meet that standard, well, then there's no more effort needed to be spent on them. So I'm going to talk now about a little more specifically about our nitrogen removing biofilters. And what they do happens all over the continental shelves around the world. It happens in forests all around the world. And it's called biological nitrification denitrification. We just speed that process up with this technology. So we take septic tank effluent from a septic tank, gets piped into a sand bed where there's 18 inches of sand, just C33 concrete sand. And that's all very oxic. As that wastewater percolates through that sand, it gets oxidized. So it's transformed from compounds like ammonia or urea into nitrate. From nitrate, it can be denitrified with carbon. You need carbon for that process, and we get carbon, or we supplement the carbon that's already in wastewater with wood chips. And you turn it into air. So that's what these systems do. They turn pollution into air. We have 3 different designs. 2 of them I've already alluded to that are in the provisionally approved phase. All 3 of them have 18 inches of sand for that nitrification. And then the first 2 that are provisionally approved, they capture that percolate, contain it so that you know how long it's sitting in that biofilter in the wood chips. So you know the hydraulic residence time, and you can control it. And you need to be able to do that. The difference between the 2 systems is that the wood chip box biofilter allows you to supplement wood chips over time, whereas the line system, it has 6 times more wood chips. You don't supplement the wood chips. The unlined system hasn't achieved the targets. But to me, it's our most interesting system, because you'll notice on the diagram there, the first 2, well, you have to line them, which is expensive, and then you have to put in those leaching rings that we see all over the county, those cement structures with the windows in them. You don't have to do that with the unlined. It goes directly to groundwater. So I'll talk a little more about these systems, but we have 26 of them installed around the county so far, and plans for more. So the wood chip box biofilter, it's averaged, since its inception, the first one went in about 7.5 years ago in Suffolk County, 11.4 milligrams per liter, or about 87% removal. In the last 12 months, it was 12.5, about 82% removal. We have another one in progress, and we have received funding from the Long Island Sound Futures Fund for 10 additional systems to put them in on the North Shore. And we're working with some great partners who have volunteered to give us residential sites on their properties. So Stony Brook School, Cold Spring Harbor Labs, the Nature Conservancy, 3 Village Community Trust, and New York State Parks. Our center is deeply indebted to these partners, great collaborators. And so our idea is, once we get 10 more systems, we'll hit the minimum to start testing for general use. and we'll test for 2 years. We think that, and so the other piece of this grant is that we've set up the bid solicitations in a way that will encourage contractors to give us low prices by economies of scale. If you give them piecemeal work, it's not as easy to get good prices. Lined NRBs, again, work very well, mid-80s removal, it's around 12 to 13 milligrams per liter nitrogen final effluent, well below the 19. Can we achieve this? All those have pumps, all those systems, every system in the county has pumps, uses electricity. Can we do that with gravity with these systems that are working well? Well, we have a prototype that's been in place for 8.5 years at the Massachusetts Alternate System Test Center, Septic System Test Center. What we did last June was we ripped the distribution off the top of it. We left the sand and wood chips in place. Those are very valuable, being aged. And we put a gravity dosing system that you can see pictured in on the bottom of the page here on top of it. And we're still testing that. So far, it's gone through the winter where it's a little harder to achieve low effluent levels, but it's been 16.6 milligrams per liter versus the 12.5 that it had before we made the conversion. So work in progress here. Our real R&D focus is for nitrogen removal is in figuring ways to get those unlined NRBs to work. So we're taking two approaches, such an important question or research area. One is a gravity-based NRB that has a Septisurge dosing system and an Elgin disposal system attached to it. Second is what we call a multi-layer NRB. So that gravity system, basically the wastewater comes out of that septic tank, builds up in a dosing reserve to a certain elevation, which triggers the Septisurge to basically flush that septic tank effluent into the Elgin geotextile sand filters. And those sand filters sit in an unlined NRB, 18 inches of sand, 18 inches of sand and wood chips. Will that work? Well, Indian Health Services in Shinnecock Nation put in these systems over 3 years ago, and we've been monitoring them since. What you can see, these systems use no pumps, no electricity, have very low O&M, and what you can see, there's a typo there, I apologize, please disregard that. 5 out of 6 systems get 4 or less milligrams per liter. So the outlier there brings the average up to about 12. Another example of a partnership, Suffolk County Water Quality, PRP, awarded our center money to install 5 of these systems, exactly identical systems in Suffolk County. And we're going to be putting those systems in the next several months. So within 15 months, we'll know if we have low-cost systems that produce very, very low levels of nitrate. The multi-layer I mentioned before, it's the unlined system, but we break up that wood chip biofilter because what we noticed from our earlier work with those unlined systems is that even though the water percolates very evenly through the sand, when it hits the sand and wood chip, it begins to get preferential flow. So what we've done is put every 6 inches of sand and wood chips, we put 2 inches of 3/8 inch pea stone. That does 2 things. It causes a capillary rise, slowing the percolation down, allowing more treatment time. Secondly, it spreads more evenly so we don't get that preferential flow, which speeds up and reduces the treatment time. How's that worked? Well, we started this in March of 2023. And over that period of time, we've had to amend the influent so that it's Suffolk County-like. Suffolk County has really high septic tank effluent levels because we monitor it at those 26 sites I showed you earlier. It's over 90 compared to in the 60s as a national average, so 50 times the national average. The unlined system we use at Mastic as a control. It's right next to the multi-layer, receives exactly the same wastewater. It reduced that 90 plus effluent by half. The multi-layer reduces it by 84%, consistently 15% milligrams per liter. Again, no septic, no leaching rings, no liner, do it in much less time. So a couple general observations about nitrogen-removing biofilters. They are truly made in Suffolk County. Local sand, local wood chips, and local labor. Our center is working with installers to increase the base of installers who are able to do these installations. We also are often asked what wood chips work best, and the answer is oak. It's also a good idea not to have debris in your wood chips, and if you're interested in that, I can talk to you about it at lunch. How long do wood chips last? Well, we have, again, with a collaborator, Massachusetts Alternate Septic Test Center, we've been working with them. We have a wood chip box NRB up there, been in place almost 10 years. Since inception, it's been getting 11.5% milligrams per liter total nitrogen final effluent. In the last few years, that level has risen, so in the last 12 months, it was 16.5, still passes Article 19, but not as good removal. What we did was we took some wood chips out of the system, and we put it in a bench scale experiment where we loaded it just like in a wood chip box, upflow. We loaded it with 31 milligrams of nitrate, and it reduced that to 3.3. In other words, 89% removal, exactly what it got when we first started out 10 years before. In the first several years, we were getting high 80s removal. The point here is that the remaining wood chips have not lost their denitrification capacity. They still work, but they've been denitrifying for 10 years, so there's less of them. In this particular system, about 20% less of them. So what do? Well, you could supplement, because you can open that wood chip box and put more wood chips in. How much more wood chips do you need? Well, about half of what would fit in a Ford 150 pickup truck. So supplementing is just part of ordinary O&M. And then the lined and unlined NRBs, well, they have 6 times more wood chips, so they're lasting decades and decades. They, excuse me, they do take up more land. That sand bed is big, about 600 square feet for a 4-bedroom house. But there's something that comes with that large sand bed. Because, as Chris has mentioned, it's not just nitrogen that's in our residential wastewater. There are pharmaceuticals, personal care products, organic contaminants, phosphorus. A lot of other things you wouldn't like to drink, like anticonvulsants, or I personally wouldn't. And so we had Dr. Tricia Clyde got her degree studying our NRBs and how they treat organic contaminants from common household products. And what she found was that not only are NRBs capable of removing organic contaminants from personal care products, but they do a better job than conventional wastewater treatment systems, or as good. But more importantly than that, she found it wasn't just that large sand bed was absorbing those contaminants for a problem for a future generation. They were metabolizing those contaminants, getting rid of them, and that's really critical. A driving force in this was her professor, Bruce Brownell, who is one of the founding members of our center and made enormous contributions. Very unfortunately, and very too early, he died last year of ALS. And so he is certainly sorely missed at the center. I'd like to talk about coupling these wood chip biofilters to commercial technologies that are available for nitrogen removal. Just very briefly, Massachusetts, one thing that those AIs, those nitrogen removing systems are referred to as AIs, one thing they're really good at, because they have aerators, is nitrifying. They nitrify really well. If you look at what's in their residual wastewater, it's nitrate. So you put a wood, it's because they're carbon limited. So if you put a wood chip box on the back to supply more carbon, you can get some really positive results. Massachusetts has just created a best available technology standard of 10 milligrams, not 19, 10. So to get down to that, how do you do that? Well, a wood chip box polishing unit is one way. We put one of these down in Wainscott back just around the time of COVID. It's been averaging, the system itself, the IA itself, didn't meet the 19 milligram target. It's been about 25 milligrams per liter. Our wood chip boxes reduced that to 9. We put another, actually better designed system in Sag Harbor, and same influent coming from that IA in the mid-20s, it's reduced it to under 4. We just put one in Montauk. We want to put a lot more of these in. We're doing that because there's no secondary treatment in Long Island soils, or most of them. The percolation rate is too fast. So we're working with a global manufacturer to install, test, and optimize more of these systems so that we can get really low nitrogen levels. I'll talk very briefly about urine diversion. So urine diversion, the idea here is you first separate it, store it, disinfect it, and then you can either apply it directly or you can capture the nutrients. In general, that's a really good idea because, one, there's a lot of places where it's really difficult to put in an AI system or any kind of on-site system, like a beach, a public bathroom at a beach. It's difficult because the strength of the wastewater, the nitrogen is really high. But most of that nitrogen is contained in urine, not in other components. So you can save a lot of valuable clean water that could be used for better purposes or other purposes than flushing a toilet. But there's even more benefits in Suffolk County because New York State parks, all of those parks now segregate their wastewater. So we have a source of urine. We don't have to, like they have to in some states, pass plastic bottles around the university to do this testing. It's we get it from the New York State parks. We have a sole source, as you all know, of very valuable drinking water in the Magathie and the Lloyd, and we need to protect it. Also, we import a tremendous amount of nitrogen in synthetic fertilizers. So back in 2009, New York State Department of Agriculture estimated how much nitrogen we're importing into the county in the form of synthetic fertilizers. That number was almost 4,000 tons. For comparison, there's about 1.5 million people here, I think, and your average person produces about 10 pounds of nitrogen per year. That's what's going into our wastewater stream. So that's about 7,500. So just what we're importing in synthetic fertilizers, that nitrogen is over half of the total that humans are producing. So also, we don't just have supply here, we also have demand. There's a huge turf grass industry. We're not selling a lot of potatoes out of state now. And I think most of you will probably agree with me, Long Islanders care about their lawns. So there's a huge lawn care market. So how can we make this urine diversion, recovery, and reuse work? So we did try direct application. It's not for everyone. Some farmers up in Vermont do that to grow hay. I tried it, but it's not just the smell, it's really expensive to transport urine around. It's too much volume. So after we pasteurize it, we capture the nutrients. Right now, we're using zeolite. There are a number of different types of zeolite. It's a very common, inexpensive mineral, and we've tested it at different liquid to solid ratios and different types of zeolite to find what works best. And then we put it on plants in the soil to see how it works. The process that we've developed is a sequential process of applying the fresh urine to zeolite. Some zeolites work better than the others. You can reduce the wastewater, the nitrogen in the wastewater, to levels where we could just introduce it into the environment with this process. How does it do on plants? You see the red arrows in the graph? Okay, those are zeolites. One is chabacite, one is clinoptilite. That's treated with urine. And the y-axis here, that's the biomass of that turf grass. So the experiments that we did have demonstrated that zeolite treated with urine does better plant growth, turf grass growth, than does commercial fertilizers, than does soil only, than does urine, or just the zeolites themselves. So next steps, we want to make sure we're in the process of it now, that none of that zeolite contains any undesired byproducts, co-products. And then we're going to be looking for collaborators who can help us in the field to prove that this technology is scalable. So I'd like to thank our funding agencies, USDEC, and then for the individual projects, EPA, National Fish and Wildlife Federation, towns of East Hampton and Southampton, as well as the Suffolk County Water Quality PRP program. None of this presentation would have happened without the work of the wastewater team. Caitlin Asado here did most of the analytical work you've seen in the presentation. Kristen produced the numbers. Luke and Julie get the wastewater, and Shaolin has helped on the recovery and reuse. Also, acknowledge Walter DeWittiak, who's been a tremendous help at the center, a great guy to bounce ideas off of. And our external collaborators, George Heufelder up at Mastic, David Rhodes, Tom O'Dwyer, and Steve Clough. Very pleasure working with these guys, local PEs, and also Bob Governale, a real shout out to him. He knows a tremendous amount about water and soil. And also the people in DHS at the Office of Ecology, Jennifer Fries, Julia Priolello, and Ken Siegel. Our center is all about partnership and collaboration, as Chris said. So thank you very much. I look forward to taking your questions. Those are pictures of NRBs. They look like someone's lawn.